So today I'll do the implementation on Cisco packet tracer. Uh, I will implement the NAT, both static and dynamic, and with that I will also implement the DNS, DHCP, and HTTP functionalities. For these, we know we need some devices like routers, switches, PCs, and servers. So in this part I am just taking those devices into the viewport, and I will connect them with appropriate cables. So I think there is no more necessity of description in this part. You can jump to the next section for more information regarding the setup. I want to mention one thing here. Instead of using the automatic connection for connecting the routers, I have chosen to use the copper crossover cables, the dashed cable in Cisco packet tracer. We can also use the serial cables, but as we follow in our labs, we usually use the copper crossover cables to connect the routers, so I am doing the same here. So in this part I will assign IP addresses to the network segments. First I will plan to which network segment I will assign which IP ranges or addresses, and then I will assign them by going to the devices, user interfaces, or configuration, terminal, etc. So for the connection in between the routers, I will select IP addresses that are from public ranges. So I have chosen 70.000 and 80.000. This is we can say like the internet. This is outside our private networks, that is on the left and the right. So these 70 and 80 series IPs, they are public IP addresses, and we can say for the NAT1 router that is written on the left, this router is kind of like a ISP's router, and this ISP has the IP ranges of 70 series IPs, and the NAT router on the right has the IP addresses available from the public domain, the 80 series IPs, and the private network on the left will use the 70 series IPs when the messages are passed outside the network, and the devices on the network on the right side will use the 80 series public IPs when the messages pass from inside to outside of the network. And for two private networks, I have kept the same IP address, the same private IP address, but their public IP addresses will be different, because the ISP on the left side will use the 70 series IPs, so the private IP on the left will use those 70 series IPs, and the public IP on the right side will be 80 series, and the private network will use those IPs. So according to that plan, I have planned to assign the IP addresses, and also of in between the two routers, the NAT 1 and the router 1, I have planned to assign the 70.001 to the FA10 port, and 70.002 to the FA00 port, and accordingly on the NAT 2 and router 1, FA10 and FA10 ports. Now it is time for IP assignment. We know that for the servers we must assign static IPs. It's not a must, but in this scenario we will assign static IPs to the servers especially. And for servers on the left, the DHCP server, I have assigned the 192.168.10.2 IP, which is a private IP. And for the HTTP and DNS server on the right, I will assign a private IP, and also I must decide on a public IP that I will statically map to this private IP, because on the network on the right side I will use static NAT. So for each private IP that I am going to use for a device, I must also select public IP, and this public IP must be from the 80 series network, because the ISP on the left has the 80 series IPs available, so you have to keep that on mind. And after that I will assign the IP addresses one by one. I will go to the user interfaces or configuration interfaces of the DHCP server first, and then I will assign its own private IP. And the private IP is 10.2 for the DHCP server, and the subnet mask is default. The default gateway will be 10.1 as we have always seen, and the DNS server will be here we will use the public IP address of the DNS server, because if we use the private IP, it will not be accessible from the network on the left, because we know that private IP is not accessible over the network, and that's not valid. So inside the DHCP we have set the DNS server as the public address, and also we will configure the DHCP services here. First I will turn it on, and then I will set the default gateway. This is for the network on the left, so the default gateway will be 10.1 here. And DNS server, again we will use the public IP address of the DNS server, and the start IP address will be the first available IP address that has not been used already. So on the left network, the 10.1 and 10.2 has been already used, so the start IP address will be 10.3, and we don't have to think about anything else. We can just save and turn the DHCP service on, and then we will go to the desktops, and from there we will request the DHCP for IP addresses, and the PCs are getting the IP addresses correctly along with the DNS server addresses. So for the left side, the configuration of DHCP is done. Now we are configuring the HTTP server, and again we have to give the HTTP server its own private IP addresses, subnet mask, default gateway, and here for the DNS server's address we can use the private address of the DNS server, because the DNS server and HTTP server is in the same network, so HTTP server doesn't need the private IP address of the DNS server to access it. So here I am using the private IP address of the DNS server for the HTTP server, and then we will configure the IP addresses for the DNS server. We will give the DNS server its own private IP addresses, subnet mask, default gateway, etc. So after configuring the IP addresses for the HTTP DNS server, I will configure the NAT1 router and assign IP addresses for its ports, the FA00 and FA10 ports. So I have planned already, and I will just assign the IP addresses and turn on the port status, and also for NAT2. So this part isn't anything new. We have done this IP assignment to the ports already, so I think no description is needed here. And also for FA10, the port that we are configuring now, we will use the 70.001, and for the FA00 port on router on, we will use the 70.002 IP addresses. So in this way we will assign the IP addresses for the remaining ports. So for the network on the left, I will implement the dynamic NAT, and for the network on the right, I will implement the static NAT. The specialty of static NAT is that for each private IP, there is a specific public IP that the private IP will be translated to. So there is a one-to-one mapping in the static NAT. So first we will configure the static NAT for the NAT2 router. For that we have to use the CLI interfaces. There is no user interface for configuring it as far as I know. For this reason we have to write our commands on the notepad, and then we'll copy and paste it in the CLI of the router. First I am writing the commands for the NAT2 router, the static routing implementation. So first is the enable and configuration terminal, then there is interface FA10, and for that we have to write IP NAT outside. So FA10 port is on the other side of the NAT router, that is towards the outside, and FA00 port is towards the inside of the NAT2 router. For this reason FA00 will be labeled as NAT inside, and if there are different port levels, we will have to do this for those port levels accordingly. And then the static NAT IP assignments. So the comment is IP NAT inside source static. It will always be inside, not outside. So it will be IP NAT inside source static. So first, after the static, we will write private IP. So here I have written the private IP of the HTTP server, and after that I have written the public IP of the same device. And we also have another server, so its private IP is 10.3 and its public IP will be 80.004 as we have planned earlier. So if there are more devices, we have to allocate IP addresses for those devices in the same way. And after that we will write exit, and from there we can write the show IPNet translations to verify if the static NAT has been set up correctly. So we will copy that and go to the CLI of the NAT to router, the CLI, and from here we will also have to make sure to go to this specific portion. We have to keep putting exit and enter until we reach here, and here we can paste our command. So here there is no error in here, so we will press enter again, and we can see that the mapping of private and public IP addresses has been listed properly here. So static NAT configuration is done, and after that we will configure the dynamic NAT on the network on the left side. For dynamic NAT, we will also have to define the inside and outside again. For the NAT1 router, the inside is according to the diagram, the FA00 is inside and FA10 is outside. So we will copy those comments from the previous configuration and edit those if necessary. So FA10 is again outside and FA00 is inside, same here, so we will not have to change anything. And for the dynamic NAT, we do not specifically say that this private IP address is mapped with this specific public IP address. We have to create a range. The range of private IP addresses that we have to translate is created by the access list. So we will have to write the access list, then the name of the access list. Here I have given the name as 1, and after that we have to write permit, and then the range of private IP addresses that I have. So here I have used the 10.0 IP address, so I will write that 10.0, and after that we have to write the reverse of the subnet mask. So for class CIP, we know that the subnet mask is 255.0.0.0, but here we have to write the reverse. So in this way we create the access list, the list of the private IP addresses that we have in the network, and again we have to create a range of the public IP addresses that our ISP has available for the NAT. So to create that list of public IP addresses available to the ISP, we will have to create a pool. So for creating that, we will write IPNAT pool and then name it the pool 1, and then the public IP address that we have available here, it starts from the 70.003 because we have already used the 70.001 and 002 on the router ports. So in this range will start from 70.003 and it may end on different numbers. That depends on how many IP addresses the ISP has. So I have taken here the 70.0000. So the public IP addresses available to the ISPs 70.003 to 70.0000, and the net mask that is default I have kept for the class A IP addresses to 55.0.0.0, and then we will have to map those pools and list together with the last command, and finally we will paste everything in the CLI. But first we must make sure to go to the appropriate section. Okay, paste. Okay, if there is no error, then there shouldn't be any problems. Now if we try to show the NAT translations like before, as we have done with the static routing, there will be no output in this terminal because we are yet to send any messages from the devices on this network. Now we'll have to set up the static routing for the routers. First we will go to the NAT1 router and set up static routing for this router. For NAT1 router, the 80 series network is the unknown network, and for that reason we will put the 80.0.0.0 and the appropriate mask, and the next hop will be 70.0.0.2. and in the same way we have to configure the NAT2 router. In NAT2 router, the unknown network is 70.0.0.0, so we put the 70 series IP there, and then the mask is default for the class A. I haven't changed that. And next is the next hop. So for this, the next hop will be 80.0.0.1. So we are writing that, and then add. Next step is to modify the web page on the HTTP web server. We will modify it so that when we access this web page, we will be able to see specifically from which IP address the web page is being hosted. First of all, we tested that whether the website on the HTTP server can be accessed using the regular IP address, the public IP address of the web server, and then we will change the website on the HTTP server, and we will also put the public IP of the web server in there so that we can verify whether it is the HTTP server that we are really accessing. So we save that, and from the web browser I will enter the IP address of the web server directly, and here we can see our modified web page has shown up. Next is the DNS server. The task of DNS server is to give back the IP address of the website to the client. In here we will give a name to our website, and we will set the IP address to the public IP address of the HTTP server, and we must set the DNS service to on. We have to save it.